Welcome to the massive open online course on Aspen Plus. In today's lecture, we will learn about the safety analysis using Aspen Plus. The safety analysis will be found in the Aspen Plus window over here in this corner. This is the place you will find safety analysis. But if you just go and click on this safety analysis, it says simulation needs to be run. Please enter simulation mode and run the simulation. That means without any simulation, we'll not be able to learn anything further. So let us do the simulation first, and then we can learn the safety analysis. But obviously for any simulation run, we need to have an example problem. Now in today's lecture, we will not take any new example problem. That means we will not start anything from scratch. We will choose an example problem which has been given in the Aspen Plus database as an example problem. We'll pick up from there, we'll run the simulation, and then we will put the safety analysis on that particular problem. So first let us choose a problem which has very minimal unit operations, so that we do not have to spend much time on the basic understanding of the problem. So for that, let us go to the file and let us open a local example. And this local example is, let us take it from, say, midstream. This midstream is for dehydration, NGL. NGL is the natural gas liquefied. Okay, so let us take this NGL and open it. So we close it and open the NGL file. So this is the NGL file. Now go to the setup and specification. It says natural gas liquid stabilizer simulation. Let us see the description. The description reads, the natural gas liquids produced from wells must be conditioned before it can be economically transmitted by the pipelines. So the conditioning process generally involves removal of brine, that is salt water, hydrogen sulfide, sand, and dissolved light gases. The high-pressure liquid from field gathering lines is depressurized and sent to the knockout drum with water boot to separate brine from hydrocarbon liquid. The knockout drum and the let-down valves can be modeled together by a flash 2 block. So we have just a flash 2 block for that, connected to a water decant stream where the free water can be decanted. To predict the amount of free water phase by the RKSWAB option set free water is yes. Some description has been given. That is not very important. The stabilization is carried out in the distillation column, which removes the hydrocarbons. I think there will be a lot of light hydrocarbons over there. Now all the components lighter than butanes removed in the stabilization column, and the amount of butane allowed in the light product depends upon the read vapor pressure specifications. The NGL and gas products are then pressurized to the pipeline pressure. Now this is very important. The NGL and gas products are then pressurized to the pipeline pressure, and we all know wherever there is a pressurized thing, there is a chance of explosion, and especially when there will be some natural gas or any petroleum product, the chance of explosion and chance of hazard is very high, and there we have very good opportunity to do a good safety analysis. So let us now go to the properties file first. Let us see what are there as components. So we have oxygen, nitrogen, methane, ethane, propane, isobutane, N-butane, isopentane, N-pentane, then N-hexane, water, and some pseudo components. Obviously, the pseudo components will have some characteristics. Let us see what characteristics they have. So we go to the pseudo components and we find 5 pseudo components, PC200 to PC600. Their specific gravity and molecular weight have been given, and the characterization data has been processed with the property method API meth. Okay, so this is the pseudo component, and these are the methods they have chosen: BK10, BWR, LS, Peng Robinson, and obviously RK-Swift. That's what they were talking about. So these methods were selected and they have run the property method and they have got some results. We do not have to do that. And go to the simulation. So in the simulation, we can see we have a separator, which actually is a flash tank that separates the gas and liquid, and obviously the free water. And off gas is released over the tank, and the cold liquid that first goes through a multi-heat exchanger where the heat is exchanged between the cold oil and the bottom product of a stabilizing column over there. This is the stabilizing column, which is a red frac column. The overhead distillate of the red frac column is fed into a compressor, and this compressor outlet is the gaseous product. Okay. On the other hand, the bottom product of the stabilizer column, after the heat exchange, it goes through a cooler, and that cooler output goes through a pump where it is pumped to a higher pressure. So here we have a liquid outlet which is pumped, and a high pressure liquid is the output over here. On the other hand, it is a compressor. So this is a gaseous product which is compressed, and the gaseous product is going out with a high pressure. So both this gaseous product and liquid product, both of them are at a high pressure. Okay. Now let us see the identity of the NGL feed. So let us go to the stream. Actually, this entire plant, it is having only one input. All other things are output, So off gas is one output, free water is an output, NGL prod, gas prod, they are all outputs. Only input is NGL feed. So let us see what is an NGL feed. So NGL feed, the temperature is 150 Fahrenheit and pressure is 800 psia. The molar flow rate has been given, and the component methane, ethane, propane, isobutane, everything has been given over here, including the pseudo components. They are also given. Now oxygen and nitrogen are not there in this. I do not know why they have taken these as components. Okay, let us see what is there in the flash 2 tank. So flash 2 tank, actually it has a pressure of 300 psia. So remember, we supply the feed at 800 psi pressure, but it is flashed at 300 psi pressure. So it is depressurized basically, and heat duty is 0. So adiabatically it is being done. So there are 3 things: vapor, liquid, free water. So 3 phases, and the gas phase, it goes through the top, we can see the temperature and mass flow rate. And we see the temperature is 142 degrees centigrade, mass flow rate is 3765. So out of 78,000 pounds per hour, we have only 3,765 of off gas, and rest of the things, so majority is going through the bottom, so in the liquid phase. And surprisingly, there is no free water over here. Let us check what is the quantity of free water, or what is the quantity of input water rather. Actually, water is 4.4. So entire water is going through the oil liquid. Okay, so if you see the results, so this is the result. Yeah, so the entire water is going through the oil field. So free water, we don't have any. So it is 0. Anyway, so the temperature has reduced to 142 degrees centigrade. So it is depressurized, and then heat is exchanged between this and this. And bottom temperature of the column is at higher temperature. So it is 377. And the heat is getting exchanged with this oil cold. So this oil is getting heated up to 250 degree Fahrenheit, whereas this bottom product is cooled to 236 degree Fahrenheit. Okay, so this oil, that is hot oil, it is going inside the stabilizer. So let us open stabilizer. It is a Radfrac column having equilibrium type calculation, having 10 stages. We have partial vapor condenser, and it also has vapor liquid free water condenser. Distillate rate and reflux ratio have been given. Oil is being fed on the 4th stage. The pressure is at 290 psia, so it was entering at 300 psia. Okay, there is a pressure drop over here in the heat exchanger. So from 300 to 295. So there is a reduction of pressure by 5 psi. Anyway, 295, and here it is saying 290. So the condenser pressure is 290, whereas column pressure drop is 10 psi. And there is no specification on condenser and reboiler. Okay, so this overhead gas distillate is going into the compressor. So let us see, it is an isentropic compressor with a discharge pressure of 1000 psi. So we had the stabilizer pressure, stabilizer condenser pressure to be 290. So from 290 to 1000 psi, it is increasing. The discharge pressure is increased almost by threefold, over threefold rather. So the isentropic efficiency and mechanical efficiency have been given. And as a result, we get the gas product whose temperature and pressure, let us see it in degree centigrade and atmosphere. So it is 128 degrees centigrade and 68 atmosphere pressure. Okay, so this is one line. Another line, the bottom product, as we discussed a few minutes back, most of the hot oil is coming down. I mean, 63,000 out of 74,000 is going through the bottom. Only 10,000 is going through the top. Anyway, so this amount of oil is getting cooled over here. So there is a pressure drop of 10 psi and the temperature is reduced to 150 Fahrenheit. So it was from 236 to 150 Fahrenheit and from 295 psi to 285 psi. So there is a pressure drop over here. And then we have a pump. So pump discharge pressure is also 1000 psi. So pump efficiency and driver efficiency, they are given. So it is a very simple flow chart. Not many unit operations are there. To be very specific, we have 1, 2, 3, 4, 5, 6. 6 unit operations. Now, first we have to run. The person who has designed the problem, they probably have run it and then saved, but from our side, we have to run it, okay, so that we can go ahead with the safety analysis. Even here, if you press safety analysis, it will say simulation needs to be run. So, would you like to run it now? You have to say yes. Let us run the simulation. Okay, now it has run. Now you can go to the safety analysis. So, go to the safety analysis. So, this is the window that you will get for safety analysis. Let us zoom to fit once again. Now, one thing that we can do is we can change it to SI unit. So for that, we have to go back to the simulation from English unit to SI unit. Or we can say metric C bar. That is okay. Run it once again. And go to safety analysis. Yes. So that's exactly what we were looking for. I think. Yeah. Now, you can find 3 things over here. PSV, rupture disk, and storage tank protection. So there are 3 safety devices that we have. We will learn them one by one.